Alright, so with this podcast, we're going to take a look at what it means to dissolve something. We're going to look at a couple of videos that were not made by me, but by other people, and I think they're really good. So the first one we're going to look at basically has to do with what does it look like to dissolve something that's ionic, and what does it look like to dissolve something that's covalent. Okay, so it'll explain those, but we kind of learned differences in our last unit, what ionic looks like and what covalent looks like. So here's the video.
What happens when stuff dissolves? I mean, like, what happens to the atoms and molecules that make it up? I want to talk about two things here that you dissolve all the time: salt and sugar. These two things look very similar. They're both like kind of white powders made up of little grains, and you can pour both of them into water and stir around, and you see the grains get smaller and smaller and maybe break apart until eventually they've totally disappeared. They've completely dissolved in the water. That's what you see with the naked eye. But if you had atomic vision and you could see the atoms that make up salt and sugar, what would it look like as these grains broke apart and became invisible? That's what we're going to talk about here. So it actually depends whether something is an ionic or a covalent compound. It depends on what it would look like when it dissolves. So over here we have salt, and this is an ionic compound. This is what a grain of salt would look like, and it's made of sodium ions, Na+, which are metals, and Cl, chloride ions, these blue things here, which are nonmetals. So salt is an ionic compound made of metals and nonmetals. Sugar, on the other hand, is a covalent compound because it's made of nonmetals, carbon, oxygen, and hydrogen. And these nonmetal atoms are connected together into a molecule. So a grain of sugar would look like this. It would be a bunch of these sugar molecules all kind of lumped together. Notice that a grain of sugar is a lot more messy. It's not nearly as well organized as an ionic compound, this grain of salt over here. Anyway, let's look at what would happen when we dissolve these. We'll take a grain of salt, dip it in the water, and start stirring around. With our atomic vision, we're going to see that the atoms that make up this salt are going to come apart from each other. They're going to break apart, and they're all going to start floating around in the water individually. This is what it looks like when salt dissolves. Okay? Now let's take our sugar. Here's our grain of sugar. It goes into the water, we stir it around, and the grain of sugar is going to break up like we saw the grain of salt break up, but it's going to break up in a different way. It's going to break up into the individual molecules that made it up. But these molecules are not going to break up into the individual atoms. They're going to stay as molecules, and those molecules are going to start floating around in the water. A big mistake that people make, I don't want you to make this mistake, is they think that when sugar or other covalent compounds dissolve, they think that the atoms that make up the molecules totally break apart. And then you end up with a glass of water that has all these carbon and oxygen and hydrogen atoms just floating around. That does not happen. Big red X. Instead, the molecules stay together. Well, the atoms in the molecules stay together. So this is a big difference between how covalent compounds dissolve, where the molecules stay molecules, and how ionic compounds dissolve, where the grains of these things like salt actually break apart into the individual atoms. So, to answer the question, what does it look like when something dissolves in water? The short answer is, it actually really depends whether you're talking about an ionic compound or a covalent compound. If it's an ionic compound, it's going to break apart into all of the individual atoms. But if it's a covalent compound, the clump of the molecules will break apart into individual molecules once it dissolves, but the molecules themselves will not break apart into atoms. They will stay as molecules dissolved in the water.
Alright, our next video is what we're going to look at is really at the molecular level. What does it look like if something's ionic? What does it look like when it's dissolving? Alright, so everything that we dissolve typically is going to be dissolved in water. So this video is going to introduce what water molecules look like in relationship to our salt crystal, or our sodium chloride. Here's the second video.
When an ionic substance, such as sodium chloride, is placed in water, water molecules interact with the ions on the surface. If the salt is soluble, the attractive interactions with water molecules overcome the ionic attractions within the lattice. The solvated ions move off the surface and become separated in solution. Notice that water molecules cluster about the anions with the hydrogens directed toward the negatively charged ion. On the other hand, water molecules interact with the positively charged cations through the lone pairs of electrons on the oxygens.
From this last video, the main difference I want you to see, and when I don't have a good video of showing what like sugar looks like dissolving, sugar is a covalent compound, but with ionic compounds, you have a water molecule, alright? And I'm just going to draw it kind of real quickly here. We might have something that looks like kind of a circle, and maybe kind of some circles down here. So our smaller circles are our hydrogens. So obviously the formula for water is H2O. And this bigger circle is O. And what the video kind of is, how it's summarized at the end, is the O side of the molecule is known to be partially negative, alright? And the positive side of water, or the hydrogen side of water, is known to be partially positive. These little symbols are Greek symbols, they're sigma, and they just mean partial, okay? So our hydrogen side, because it's kind of positive, is going to be attracted to our anion. If you remember, anions are our negative ion. So again, the hydrogen side is attracted to the anion. And conversely, our oxygen side of our water molecule is attracted to the cation, because cations are positively charged. So because opposites attract, our negative charge is going to be attracted to our positive cation. And as we have enough waters that surround those ions, the waters kind of win like a tug-of-war battle and actually start pulling apart our sodium ions and our chloride ions. In a covalent compound like sugar, where there's not really a positive or negative, they kind of just pull at the molecules and just pull them apart as big molecules as opposed to actually ripping the elements apart or the ions apart. Alright? So instead of, again, ripping them apart, they're kind of just pulling the molecules apart. Kind of the waters just surround them, are attracted to them, and just pull the molecules themselves apart. And that's the difference between, at the molecular level, what's happening with ionic and covalent compounds.